Hello, my name is Darren Thomas. I'm the Director of Educational Research Techniques. In this video, we're going to introduce ourselves to sinusoidal functions, and we're going to focus particularly on how to understand the period inside a sinusoidal function. So let's begin. So here we need to do a quick recap on exactly what a period is, and sine and all those things, the sine function, cosine function. Now here in the upper left, I have an ugly picture of a sine function, if you will. And essentially what is happening here is that you're kind of taking your unit circle and you're stretching it into like a line where, and this is a review by the way, the first and second quadrants are kind of up here in the positive area. So you could call this, first and second quadrants like so. And then your negative information is down here in the third and fourth quadrants. And so basically what you're doing is you're taking your unit circle, and these guys right here kind of represent the top part right here. And then this stuff down here is kind of the stuff below the negative line there, the negative value. Now the reason it stops down at -1 is because the radius of a unit circle is 1. So it never goes below -1, it never goes above +1. That's kind of what's happening. And the distance of a period is basically the trip all the way around the circle when you take the unit circle and kind of stretch it out to be this sine function, if you will. So in other words, the distance from starting from right here from 2 pi all the way down here, this is going to be 1 right here. It's where it stops right here. Yes, this is going to be one period. This is the period right here. And then from here to here, we'd have another period like so. That's what's happening. And so the period is the distance when the sine function goes all the way around the unit circle, if you will, when you have all your positive and all your negative values like so. And so when we're talking about a sinusoidal function, we're talking about something that has the shape of a sine function or even a cosine function, but we're really focusing on the sine function. However, it doesn't follow all the rules completely. And so to explain that more clearly, the essential equation or the essential function for the sinusoidal function is as follows. You have y equals, I need to probably do this on the second slide. You have y equals a times sine of the quantity of b minus c plus d. Now all these different things have values for them. So, but we're not going to talk about all of them in this video. It would become too long. So A represents the amplitude. We'll talk about that more later. You just need to know that for now. B is what we're focusing on. This is the period. C is going to represent, the horizontal value, how far to the left or to the right the wave is, and the D represents the vertical values of up and down, if you will, on the y-axis. So this is kind of like the x-axis manipulation, the y-axis manipulation, if you will. And this function is how you can have something that has the characteristics of a sine function, but not exactly, which is again why they call it the sinusoidal function. All right, so that's kind of what's happening. Now, let's see if we can make this as clear as possible. Let's go to a new slide. Okay, so here we go. To find the period, basically you take 2 pi over the absolute value of b. And remember, the b is kind of the value we're manipulating for the period here. Now here's the thing. If b, now check this out, if b, the absolute value of b, if it is greater than 1, is greater than 1, the period is going to be less than 2 pi. In other words, the period is going to be compressed. All right, just put comp here, compress. Now, on the other hand, if b is less than 1, all right, we're gonna have a period that is going to be stretched. This will make more sense when you see a picture. That's kind of what's happening. Now, the question we need to address before we deal with whether it's compressed or stretched is, well, how do we get the value of b? Well, this is the secret right here. So, let's say I have the following. I have sine of x. All right, so in this particular situation, the b is going to be 1. All right, because it's always kind of like the value in front of the x, and so when you have x, it's like 1x basically, and you don't put that obviously, so it's just 1. If I have the sine of x over 2, well, okay, in this particular situation, the beta is going to be 1 over 2, like so. And if I have something like sine, oh wow, messy, sine 2x, you can see that in this particular situation, the b, I like to call it beta, I love statistics, but the b here is going to be 2 because we have this coefficient 2 in front of the x. That's what's kind of happening. So this is kind of the rule. Wherever the variable is at, that's probably where it's going to be at, and it's always the coefficient in front of it. So here x, basically you have 1x divided by 2, so you have 1 over 2 basically. Here you have 2 times x, so you have 2. Here you have 1 times x, so you have 1. That's kind of how you're able to figure out what the b is. And so when you do this formula right here at the top in the upper left-hand corner here, if you're following me, that is how you're able to figure out what the period is. So the b is not so much the period as it is a tool for finding the period. That's probably a more accurate way to think about it. So let's do a few examples. But let me first of all draw you a little picture here to try to make this as clear as possible. So I'm going to go ahead and draw my little scale here. And so I want to make this nice and long and clear. And we're going to plug in the different values from the previous slide into this one. So here we go. I'm going to start with, by labeling my graph obviously, we're going to start with pi over 2 here. And then we're going to have pi about right here. And then we're going to have 3 pi over 2. And then we're going to have 2 pi, like so. All right. And then of course we go up to 1 and we go down to -1. All right, now here we go. Let's draw our first one. So just to make it simple, we're going to have sine of x. All right. And so that means that our absolute value of beta is going to be 1. So if I do 2 pi over 1, because that's my beta right there, I'm going to get the answer of 2 pi. So this is the length of the period. So it'll be something like this. It'll go up, go all the way, and then it'll go down right here, and then of course it'll go up off the screen. Just that's how it looks for now. So that's the first one. Now let's do the next one, shall we? Let's do we did the sine of x over 2. I hope you remember that from the previous screen. So now we have a b that's going to equal 1 over 2. Run out of space here. But here we go. So if I plug this into my equation, 2 pi over 1 over 2, well, that's the same as, let's see here, as 4 pi. So what's going to happen is, you're not even going to see this. It's going to go all the way like this, and it's going to go off the screen before you even get one period. That's kind of what's happening. Maybe I'll redraw that on another slide. So let's do the last one now. So now we got, I'll choose another color here. We will do a sine of 2x. So that means that my b is going to be 2. And so that means when you have 2 pi over 2, is that correct? 2 pi over 2, yes, these cancel out, and you get a period of pi. So in this particular situation, you get something that is compressed. You go down like this, and you go down up like that. That's kind of what's happening. And so let me draw this on another picture for you here. I'll do that real quick. I want to make sure this is nice and clear inside everyone's head. So I need a little bit more space. That's what I need. So if I do this, again, we're just going to redraw it for the sake of clarity as much as possible. And, well, we're going to try to guesstimate these, oops, don't want that. Guesstimate these terms right here. If I redo this, you're going to see the following. So let's just say I start with pi over 2, and then I go to pi. I'm going to try to condense things here, make it a little bit better. Then I go 3 pi over 2, and then I have 2 pi, like so, and then I have 5 pi over 2, and then let's see here, that's 2.5, then I have 3 pi, then I'm just going to skip to 4 pi for the sake of clarity. 4 pi, like so. So with the first one, if you remember from the previous screen, it went up and it went down to 2 pi, and down to 2 pi. So Oh, this is pi, 3 over pi, yes. Okay, so for our first one, it kind of went up like this. It went pi, then it went, let's see here. It went up, and then, so it went up, then down, then up again, like so. And the distance to complete it was 2 pi, like so. That's how it should be. There might have been a mistake on the previous slide. So this right here is sine of x, unit circle style, if you will. Now for our next one, we had, what was it, x over 2. This one was a little bit more complicated. If I had to draw you a picture, it would look something like this. We started here, and then we went to 2. No, that's not going to work. Sorry. We started here, and then we went to 2 pi like so, and then we went down, and then we went up to 4 pi like that. This is sine x over 2, and then the last one that we're going to do is sine of 2x. That one was really, really wild. It went from, it went up, and then it went down like this, and then it went up, then it went down like this, and then it went up. That is sine of 2x like that. So keep in mind, when the b is less than 1, the period is compressed. It shrinks together. And that's why, if you look here, okay, I'm sorry, if the b is greater than 1, it is compressed. So this is what's happening with this one. If the b is less than 1, it is stretched. And so that's kind of what's happening with the blue one. And this is how you're able to use this value of b here to figure out the period. And this is one piece of the sinusoidal function. So let me go back and recap this and wrap this up. So in this video, we looked at the sinusoidal function, which is when you kind of have a sine function, but it's a little bit different from what you expect. It doesn't follow, the theoretical shape of a sine function. And so on this slide, we review what the period is and how the sine function works. And then here we pulled apart the different pieces of the sinusoidal function. A is amplitude. We'll talk about that in a future video. B helps you to figure out what the period is. The C and the D values help you to determine the horizontal and vertical shift of the function. And then here we learned how to actually calculate the period. The B is not so much the B value is not so much the period as it is used to get the value for the period. So when B is greater than 1, you're going to have a compressed period. It's going to be less than 2 pi. When B is less than 1, you're going to have a stretched out period. In other words, the period will be greater than 2 pi. And then we have some examples here at the bottom of the screen for this. All right, and so here I tried to draw, but this was not quite drawn to scale like I hoped. And you can see that how when you have the different slide values, the different values for the B, how it affects it. And so here also I try to do it, and that's kind of what's happening. So they were kind of out of order here. So this was the improved version right here. And so to get the actual B, the value of B, you have to keep in line, what's happening with your x value in the actual function, the actual sine function here. And so I explained that when sine of x, then B is going to be 1. Wherever the x is at, you got to keep an eye on that, because whatever's happening to him is what's influencing the behavior of the sine function. So I hope that this video made sense. A lot of information in this video. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.